Okay, you're live. இல்லையம்மா இருங்க ஸ்ட்ரீம் URL.
Hello.
வந்துட்டியா? சீக்கிரம்.
Hello.
அம்மா அது காமிங்க, அப்போதான் என்னால் பார்க்க முடியும்.
Hello.
தேங்க்யூம்மா, தேங்க்யூ. ஸ்டார்ட் பண்ணிடுங்க. தேங்க்யூ.
வருதா? எனக்கு அந்த ஸ்ட்ரீம் URL அனுப்பி விடுங்களா?
தாத்தா செல் அனுப்பிச்சேன், அதே தான் பழசே தான்.
Hello, good morning, dear staff. Antu ma'am, can you hear me?
Yes, ma'am, I can hear you.
Okay, thank you. Bobby ma'am, can you hear me? Hello, Bobby ma'am, can you hear me?
Yes, ma'am. Yes, ma'am.
Okay, fine. Just I'll confirm with the resource person. I'll confirm with the resource person. Dr. Benson, sir, can you hear me, sir?
Yeah, yes, I'm able to hear you.
Yes, sir. We'll start with the session, sir.
Okay.
First of all, I'm really sorry. We had an issue in the live streaming. That's why we had 10 minutes delay. We'll start with the session now. Commit to the Lord whatever you do, and He will establish your plans, says the Bible. On behalf of the organizing committee ComStar, Computer Science Technical Association, it gives me great pleasure to welcome our Honorable Principal, Reverend Dr. Sister Arokirani, distinguished guest of the day, Dr. S. Benson Edwin Raj, valued professors, scholars, and participants. A glad welcome I bring to you this morning, filled with the desires of hopes and dreams we all are going to share today. To invoke the presence of the Lord, I take this splendid opportunity to invite our Secretary and Principal, Reverend Sister Dr. Arokirani, to begin this webinar with a prayer.
You are precious in the eyes of the Lord. Isaiah, risen Lord, God of infinite love and mercy, you are a presence of inner light, source of all strength. We praise and glorify you for your great blessings showered upon us today. We raise our hearts and minds with gratitude for the gift of this day and for the opportunity to organize this webinar. We submit all the participants, the organizers, the convener, Dr. Deena Suresh, the resource person, Dr. Benson Edwin Raj, in your divine presence. Bless them with your divine light, wisdom, and knowledge, so that they will be the messengers of your love, peace, and source of knowledge. This we ask in your powerful name, Jesus, O Lord. Amen. My dear participants, a graceful morning to everyone present here. A joyous welcome to you all. I hope this webinar will pave the way and it will provide some new frontiers, new look, new techniques in all the challenges of this pandemic period. I wish you all good luck and God's blessings. I appreciate the head of the department and her team members for their new efforts and initiatives to organize this webinar on blockchain technology. May the good Lord bless you all. Be a blessing today. Have a joyful day.
Thank you so much, sister. Thank you so much. I feel privileged to help.
Thank you so much, sister. I feel privileged to extend my warm welcome to invite our chief guest, Dr. S. Benson Edwin, Associate Professor, Department of Computer Information Sciences, Higher Colleges of Technology, Fujairah Women Campus, United Arab Emirates. Let me give a very brief introduction about our chief guest. Dr. Benson Edwin is a doctorate in the Faculty of Information and Communication Engineering specialized in network security. He has completed his Bachelor's of Engineering in Computer Science and Engineering at Madurai Kamaraj University, his Master's of Engineering in Computer Science and Engineering at Anna University, Chennai, and his doctorate in the field of Information and Communication Engineering specialization in Information Security in Anna University, Chennai. He has nearly 20 years of engineering experience in India, Oman, and UAE. He was working as assistant professor in the School of Computer Science and Technology, Karunya University, India. He was a head of major information security and lecturer in the Department of Information Technology, Rustek College of Applied Sciences, Sultanate of Oman from 2012 to 16. He is currently working as associate professor in the Department of Computer Information Science in Fujairah Women Campus, UAE. He has successfully passed the IBM Academic Certificate Exam for Blockchain Developer Mastery Award in 2019, IBM Academic Certificate Exam for Web Application Security Engineer Mastery Award in 2019, IBM Academic Certificate Exam for Security Intelligence Analysis Mastery Award in April 2017. He was a co-principal investigator of a funding project from the Research Council, Oman. He has also received the Best Faculty Award from Karunya University, India in 2007. He has published many papers in international and national journals too. He has been invited in many institutions as guest speaker. He is an honorary member of the Campus Council and Higher Colleges of Technology, Fujairah Campus, United Arab Emirates from 2018 to 19. He was an international advisory board in the first international conference on recent trends and challenges in computation models in 2016. He is a research project reviewer in Qatar National Research Fund from 2015 till date. He is a research project reviewer in the Research Council Oman from 2015 till date. He is a system coordinator network security in Rustek College of Applied Sciences Oman from 2013 till date. He is also a member in Internal Audit Committee Rustek College of Applied Sciences in Oman from 2013 till date. He was an academic council member, board of studies member, university coordination committee member, and a member of purchase committee in Karunya University, India from 2005 to 11. He is also a Cisco certified network associate academy certification holder. I welcome our resource person, Dr. S. Benson Edwin. Welcome you, sir. I once again wish to extend my hearty welcome to one and all present here. You all have rendered your valuable time from your busy schedule, and without you all, we cannot even think to make this webinar a grand success. Many of you have made a huge effort to join with us today. Welcome you all, and sorry for the 15 minutes delay. Welcome you all. I now request Dr. S. Benson Edwin to take over the session.
Good afternoon, everyone. Are you able to see my presentation? Yes, can you please acknowledge someone? Are you able to see my presentation?
Yes, sir. We are able to see.
All right. Okay. Praise God for this wonderful opportunity. Happy to be here to share with you on the topic blockchain technology. Thanks to the principal ma'am for your concern and hearty welcome, and thanks to Ms. Deena Suresh for giving me this opportunity. So I am Dr. S. Benson Edwin from Higher Colleges of Technology, Fujairah, UAE campus. Today we are going to discuss about the topic on blockchain technology. So I have these topics to be discussed today in a quick span of time. So we will start with what is the current problem, why we need blockchain, what's special about blockchains, how a blockchain works, blockchain versus Bitcoin, what's the difference between public blockchain and the private blockchain, how to build a blockchain solution, And finally, some research challenges that is involved in blockchain. So if you have a question, maybe at the end of the session, you can type in the chat. Right now, I'm not able to see your chat messages. Maybe Dr. Dina Suresh can send me in WhatsApp, or later on, once the presentation is over, I will take the questions for you. So I will share my email ID also, so that if you have a question related to this, you can surely contact me for further things. What is the current problem? Why we need blockchain? The problem here is, how do we tell something is fake or legit in today's real world? Just take, for example, we come across many things in today's real world. How do you tell it is fake or real in today's world? Example, take a rupee. There are fake rupee notes. Take a driving license. People can forge a driving license, have a different name, different ID, different number. Voter IDs. Voter ID could be forged. Duplicate IDs can be created. Of course, we all know it. And organic food. You go to a supermarket and you see something, a food named as organic. How do you trust it? Is it really organic, or you just trust the label just written as organic? The owner of the land, yes, this is a very important example. There are a lot of land disputes today. Who owns this land? Sometimes you see the same land is owned by more than 3-4 people having the same document. Of course, for sure, only one owner or one document is the real one, whereas the rest is going to be fake. How do we know that? How do we tell something is fake or legitimate in today's real world? That's the confusion. So basically, there is a central authority that's keeping a record of it. If you want to see a rupee, RBI can tell whether this rupee, the serial number for the rupee is the correct one or the fake one. RBI can tell it. If you go to the driving license, every driving license has a unique number, and the driving license department can tell whether it is right or wrong, and so on. So generally, most of the to tell whether a document is real or fake is based on the record. That is most probably maintained by a central authority. Generally, you see there is a centralized ledger. They maintain all the documents. If you go to the Tahsildar office, they maintain the Patta document, who is owning the land and so on. If you go to them, they may have the reference to it. Now, what is the problem? Central authorities, whenever there is something is central, they have lot of powers, and it's going to be corrupt. There is a famous saying: history is written by victors. Whatever we are learning in the history, we don't know whether it is true or whether it's fake. So, as history is written by victors, whoever has won the battle has changed the history. So, whatever we read, we need to believe it. Someone decides to change the record, how much money is owned or owed. Being it as a life, of course, we all live in a corrupt world, and it's a centralized authority. It's easy to be corrupted. Since it's a live stream, I cannot cite many examples on corruption. You can find out more examples. Of course, each and everyone here, I am sure, are a member of this as a part of this corruption. So the solution to it, whenever there is something, there is central authority, there is a lot of power and corruption, the solution to it is go for decentralization. So whenever there is decentralization, it reduces the risk of corruption, fraud and manipulation. So if you see, blockchain is a new and innovative way to implement decentralization. The buzzword behind blockchain is decentralization. It's a shared immutable ledger for recording the history of transactions. So what happens in decentralization? Do you think the risk of corruption is less? Say, for example, when you go to a bank to a teller to withdraw some money, you give him the slip, you give him the withdrawal slip. The teller verifies your balance, and then he checks your withdrawal slip. Later on, he signs and passes on to someone else. To decide whether to give your money, he signs, then he passes on to his manager. If the manager sees the withdrawal slip, he verifies once again, and he also acknowledges your transaction. Then later on, the teller gives you the money. If you see, in case of decentralization, there is more than one person to validate the transaction. In this case, the chance of corruption, the chance of fraud and manipulation becomes less. So when you look at the proper land document, if it is maintained by a centralized authority, that is where all the problem comes. So, where people try to pay money to the corrupt system, and then they try to change the owner of the land or try to register in someone else's name. But if it is decentralized, where more than one has to approve it, the chance of corruption, fraud, and manipulation becomes less. So the ledger here, imagine a ledger is a database or a file maintained. The file here is maintained in a distributed way, not in a centralized manner. In a regular system, what we see today, it's all maintained by the central authority. But in blockchain, this ledger, the file or the database, is not maintained by a central authority, but it is maintained by distributed set of participants, distributed set of people. Everyone has to validate, so the chance of fraud, risk, and corruption becomes less. Another best example is internet. Internet was actually formed to be a best decentralized system, but today it is not actually a decentralized system. Internet is controlled by a few powerful players like Google or Amazon and so on. It becomes more centralized. I funnily tell my students, you watch the web and the web is watching you. Of course, everyone of us might have felt it. I was searching for a particular course referred by my friend in Google. Next day when I was looking for when I was watching a particular video, the advertisement that comes was exactly related to the course I was looking for. And you are watching the web and the web is watching you. So the internet is more of, it was supposed to be a decentralized system, supposed to be everyone supposed to share their information, and it was supposed to be decentralized. But today it is controlled by a few top players, and they decide what you want to see and what you want to what information you need to see. So basically, we are moving from a client-server architecture to a peer-to-peer. So where are we now? Most probably, if you see Web 2.0, Web 3.0, the web generations, we are all sitting in the client-server model. Like you check Google or Gmail or Facebook or Instagram or whatever is the application today we are using on the internet, most probably these applications are client-server based. But blockchain requires a peer-to-peer network. Each participants have equal rights. Each participant maintain a ledger. To validate the transaction. So a peer-to-peer network, every participant have equal rights in a peer-to-peer. So what's special about the blockchains? The way it tracks and stores the data. As I said, it's a decentralized system. It's applied in a peer-to-peer network model. More than one are going to validate a particular transaction, a chain of blocks. If you see here, let me just get to the next slide and describe what is a block and what is inside a block. So what's special here, there are 3 points. I'll revert back to this slide. I would like to highlight on the third point, the other important reason why we need blockchain is there are no more intermediaries. So today, the whole world is controlled by intermediaries. If you see here, there is a farmer who is cultivating the vegetables, but when he comes to sell it, there is an intermediary, a broker, or a supermarket, or a broker intermediary. It's not straight away between the people buying directly from the farmers. There are intermediaries. I am sure you all will agree with me. Who is benefiting the most? Is it the farmer? No. Is it the people who buy the product? No. It's the intermediary who is in between, the broker. So he is mostly benefited, and least benefit goes to the farmer and the people. We pay more money to buy the products, whereas the farmers sell their products for a very, very less cheaper money. So that is one of the second reason why blockchain comes in place. It removes all the intermediaries. If you want to look at blockchain, remember these 2 reasons. Number 1, it supports decentralization. As we all know, the centralized system is corrupt. Number two, here there are no intermediaries. Another example, if I want to transfer a money from my account to my friend's account, there is an intermediary, the bank. Bank is a central authority. Bank is an intermediary. They take some money from my side, they take some money from the sender as well as from the receiver. It's my money, I want to transfer to my friend. It's straight away between A and B, or sender and the receiver, but unnecessarily we are paying several lakhs and lakhs of money to the central authority as a brokerage fees or as an intermediary fees. Look at MasterCards, Visa cards. What do? They all for every transaction you make, for each and every transaction you make, they take a commission. So which means whenever there is an intermediary or a central authority, they act like a broker, they take your money, and the benefit doesn't goes to the end users. When you look at a peer-to-peer system, look like if A wants to transfer money to B, A is directly transferring money to B without any third party. In this case, there is no brokerage fees, there is no commission, the transaction is straightforward, and there is a trust in the transaction. So what happened, that's mostly about blockchain. As I said, it addresses two important problems. It addresses the problem that arises with having a centralized authority. Number two, it removes all the intermediaries in place, being a peer-to-peer network. So if you see in a peer-to-peer network, there is no intermediaries. Everyone all the participants here are having equal rights in a peer-to-peer network. So blockchain works on a peer-to-peer model, peer-to-peer network. So what's special about blockchains? The way it tracks and stores data, a chain of blocks. So what's inside a block here? If you see a blockchain is a chain of blocks that contain data. So every block, when you say a block, imagine it like a database or a file that stores certain information in a particular block. Just for example, if there is a person A wants to transfer money to B, I write $100 or something like this. So I write the sender is A, the receiver is B, and the transfer amount is $100. That will be in block 1. So generally, the first block we refer it as a genesis block. Block 1 we refer it as a genesis block because being it as a first block. So the subsequent transactions that will be created into different blocks, and these blocks are linked closely. That is why it's chained or linked closely. The second transaction, take for example, A wants to transfer to C another $50. It is written in block 2, for example. It is written in block 2, and block 1 and block 2 are interlinked. So what happens here, these blocks are immutable. Once a data is written in a block, you cannot go and modify the block. So for example, A is transferring B $100, that's it. It's written in a block. This transaction, once validated and complete, it is stored in a block, and no one can change this block. We literally say it's immutable. Immutable means you can't go and change, or you cannot go and modify the blocks. It creates the trust in the data. That's the point in a block. If you see here, what happens in a block? What is there in a block? The transactions, as given, the transactions are given in a block. The hash code of the block is there in every block. So basically, in blockchain, it looks into the cryptographic techniques. I wanted to tell a small point related to the hashing technique, so you understand how the blocks are becoming immutable. So hashing algorithm is a cryptographic techniques. Hashing algorithm is a cryptographic technique that provides integrity to the data or integrity to the block. Let us take this example. Look at this example here that shows the input and the digest. So what is in between is the cryptographic hash function. So the cryptographic hash function takes a particular block and computes the digest or a block. Let us take, for example, row number 2 and row number 3. The row number 2, imagine it's a block that contains some information. The information says the red fox jumps over the blue dog. When you take a cryptographic hash is a unique value computed from the block, from the message. So it takes this input message and computes a unique code, generally referred as message digest. So if you see here in row number 2, the message digest is 008646BB and so on. Imagine row number 3. There is a small change in the block. The red fox jumps in place of over, they replace V with U. There is a minor change in the block. So whenever someone changes the block, you see the cryptographic hash function output, the digest, it's totally changed. 8FD8 and 7558. Compare the digest between row 2 and row 3. These digests are totally different. When a block information is changed, minor change in a block information will certainly change the message digest. This is what happens in a block. You see there, the diagram, the blocks are interrelated. Every block has the hash value of the current block and hash value of the previous block as well. So here comes no one can tamper into a block, because if they make a small change to the block, as in this example I just said, you make a small change to the block, what happens? The hash code will change, and everyone will know that this block has been tampered or this block has been modified. So the basic principle behind this block, immutable block, is on the hash functions. So if you go back here, that is where every transaction is written in a separate blocks, and the blocks are linked to each other. No one can go and change block 1 or block 2. If something is changed, everyone in every participant in the network knows that the data has been compromised, or they don't validate the data, and so on. It is securely linked and it is time-stamped. You cannot go and edit a particular block of information and so on. If you want to change it, you need to create a new block. That is where it says, what's special about blockchains? The way it tracks and stores the data. A chain of blocks changed with a new timestamp. Every block added is going to have a timestamp, what date and time the block has been added. Number 2, it creates a trust in the data. Blocks are immutable. As I said, every block has a hash code or as a message digest. As I said, cryptography. Crypto means secret, graphy means writing, a secret way of writing. Blockchain trusts more on cryptographic principles. In the hashing algorithms are one of the cryptographic techniques that provides integrity to the blocks. So by binding the hashing techniques or the digest into the blocks, makes the blocks more immutable. And the third important thing about what makes blockchain more special is there are no more intermediaries onto it. So to keep it simple in plain English, this is what a blockchain is: a chain of blocks that contain data, and you cannot go and modify a block once it is written to the block. That provides more trust to the block. This is the architecture of a data chain in a blockchain network. Of course, how many number of blocks you can have? You can have any number of blocks. Every block will have the hash of the current block and hash code of the previous block. Every block can have any set of transactions, and so on. Right. This is the point. So how blockchain works? So moving to the third point, how does a blockchain works? So we have seen what is inside a block. Inside a block, there could be some transaction or some point of interest of information related to the use case. You can store it in a block and so on. How does it work? Let me take the very familiar example of Bitcoin, where generally is a kind of a blockchain, where that is kind of a banking without a centralized bank. Imagine you are going to transfer money to your friend without a need of intermediary authority, intermediary centralized authority. There are no banks, cryptocurrencies. A can transfer to B, B can transfer to C, and so on. What happens in a blockchain network? In this blockchain network, it shows there are 1, 2, 3, 4, 5 participants. There are 5 participants in a blockchain network. Of course, in reality, there could be several thousands and thousands of users in a peer-to-peer network. Here we have close to 5 participants in this example demo that is given. Imagine A wants to send money to B. Okay, so now in this case, if A wants to send money to B, the transaction is represented online as a block. So what happens here, in a block, it is going to write A is going to send money to B, sender is A, receiver is B, and the amount is $100. So this block is going to be broadcasted to every party in the network. So every party in the network will be having the ledger copy, will be having the database copy. Everyone knows how much money A has, how much money B has. Everyone has a distributed ledger. Everyone has this information with them. So they are going to validate it. So when this block is straight away not added to the blockchain before validation. So once this block is sent to everyone, all the parties has to validate or approve the transaction. Say if A wants to send money to B, $100, all the participants in the peer-to-peer network has to check with their ledger, has to check with the previous blocks, and then approve this transaction. Once they approve this transaction, then the transaction becomes valid. You see, step number 4, all the parties are approving the transaction. Once approved, we move to step number 5. The block can be added to the chain. So now, once approved, once the block is added to the chain, the money is moving from A to B, which once it is added to the chain, please understand, no one can go change or modify a particular block. This is what happens in a simple scenario in a Bitcoin environment, which we will be discussing shortly. Again, in a different mode, how blockchain works. A transaction is requested. Maybe A wants to send some money. A block that represents the transaction is created. Yes, A creates a block. What is inside a block? Block is about the sender, the sender information, the receiver information, and how much money they are going to send. So then the block is sent to every node in the network. Every node in the network means in a peer-to-peer, there are multiple participants. As I said, there will be thousands and thousands of users. Everyone will receive this block, and this block is not added to the chain unless everyone validates it. This is the point where the trust comes in. If it is a central authority, you just go and compromise a single person, the owner of the centralized authority, you pay him some money and then he changes the data. But here, it is not possible, it is impossible to do that, because you need to go and talk to anonymous 1,000 people who is going to validate your data. So in a peer-to-peer network, all the users are anonymous, all has to validate your data. Once everyone validates their data, then they are added to the this block is added to the chain, and then the transaction is going to be. This is what happens. This is how a blockchain works. Continuing to it, how does a blockchain works? We need 4 important parameters. How does a blockchain works? Number 1, you need a peer-to-peer network. You need a peer-to-peer network of computers that are equally privileged to communicate and share remotely. Of course, we know a peer-to-peer network is a group of computers that are equally privileged to communicate and share remotely. Number 1, you need peer-to-peer network. Number 2, what you need? Cryptography. Crypto means secret, graphy means writing, secret writing. Cryptography plays a very vital role in blockchain networks. So even bad actors can participate. So you need to find out whether they are modifying it, they are altering it, they are changing the information. The cryptographic hashing techniques are a part of this information, and so on. The third one here that comes here is about something that is called as consensus algorithm. Here I will be discussing few keywords that are coming coming. This is point of interest for researchers where they can work on a new consensus algorithm. So consensus algorithm, I just said, we discussed what is inside a block. We know what is inside a block. A block will contain some transaction. There will be some hash. There will be some hash code within the block that we refer it as a message digest within the block, and so on. Now, who is going to write on a block? In a public blockchain, I will come back to the difference between that. In a general blockchain, public blockchain algorithm, who is going to add a new block? That is decided by the consensus algorithm. that is decided by the consensus algorithm. So, for example, if A wants to transfer a money to B, and they say A wants to transfer a money to B $100. Okay, this block is broadcasted to everyone for validation. Now, who is going to add this? Who is going to add this block to the blockchain? There are 5 participants here. Among the 5, who is going to add it? Should we allow A to add it, or should be open for anyone to add the block? So this is considered by the consensus algorithm who is going to add a new block into it. So this is generally, they all agree. Consensus algorithm is like the computer or the node that solves the cryptographic puzzle wins the race, kind of, you know. Among 10,000 participants, anyone can run the cryptographic puzzle and then first validate the block and then say, I have solved the puzzle. I am here to add this to the block. But for adding a block, everyone has to validate. In this case, I would like to cite one more example. Let us imagine A has $1,000. A wants to send money to B $500. Now, what happens? This block, this A initiates the transaction. I want to transfer $500 to B. What happens here? There is a competition among the peer network nodes. Who is going to add this block to the blockchain network? So who is going to win this competition? The one who is going to solve the cryptographic puzzle. So it's like anonymous. No one knows who is going to win the cryptographic puzzle, and among the anonymous nodes within this network, someone is going to win the cryptographic puzzle, and then they are going to validate the block first, and then they are going to send this block information to everyone to validate. Everyone will check, yes, everyone has, because it's a distributed ledger, everyone knows what balance A had, $1,000, okay. But now what A is doing, A wants to send $500 to B. Yes, okay. Is it a valid transaction? Yes, because A has a balance of $1,000. So everyone will agree on the transaction. Once everyone agrees on the transaction, this block is added to the chain. Take the second scenario. A wants to perform another transaction. A wants to send $1,000 to C. Now everyone knows that what balance of A is only $500. How can A send $1,000 to it? So when this information comes to all the participants, they will check with their own ledger copy, their own copy of the ledger, shared ledger, and then they will say this transaction is invalid because A only has a balance of $500. A cannot do this transaction. A cannot transfer $1,000 to C. This transaction becomes invalid. All the participants will disagree on this particular transaction, and this block is not added to the chain, and so on. So here, that's the two example I just said, where all participants agree on a particular transaction. The second case, the participants, those who do not agree on a particular transaction. So how does a blockchain works? We need in general, there is a peer-to-peer network that is involved. Basically, yes, that's because of decentralized architecture. Number 2, we need to have cryptography. Even bad actors can participate because security plays a vital role there. Number 3, consensus algorithm. Example of consensus algorithm is, among the participants, who is going to add the block? So it is an anonymous participant who will be adding the block. So he will be, this anonymous participant is chosen like the winner of who solves the cryptographic puzzle first. A consensus algorithm could be as simple as a round robin method, where firstly A will add, then B can add, then C can add, or D can add. It could be as simple as a round robin method, or it could be as complicated as proof of work, where the participants are negotiating with the solving a cryptographic puzzle, winning the competition, and then see, hey, I have solved the puzzle, so I am eligible to add this block to the blockchain network. But mind it, before adding a block to the blockchain network, For sure, all the participants in the network has to agree on this particular transaction. The fourth important component in general available in public blockchains are punishment and reward systems. So it's like, you know, the reward systems, like whichever nodes, whichever peer-to-peer network, whichever node wins the cryptographic puzzle or solves the cryptographic puzzle, and then adding the block will be rewarded with certain cryptocurrencies and so on. And similarly, those who are trying to do some malpractice, there is a kind of punishment that is involved. But in general, in a private blockchain or whatever point of interest for us in real-time applications, we don't have this punishment and reward system or the consensus algorithm. In general, we have a peer-to-peer network and cryptography, and then we just try to add blocks to the blockchain. But minded, the main principle of it, before adding a block to a chain, all the participants in the network needs to approve on this particular transaction. Point number 4, blockchain versus Bitcoin. So mostly people are confused between these two terms. Generally, they say they are using these terms interchangeably, but it's not so. It's as good as telling internet and email are same. No, email is one of the use cases of internet. Internet has wide variety of applications, wide variety of use cases. Email is one of the use cases of internet. Likewise, Bitcoin is one of the use cases of blockchain. In fact, what Bitcoin came first. Bitcoin came first. Bitcoin is about cryptocurrencies. It initially originated in the dark web. As I said, of course, the objective remains the same. It was in the dark web, especially for illegal transactions, selling of drugs. People started to have cryptocurrencies, sharing their money in terms of cryptocurrencies. They don't want a centralized authority, something like a bank. So it started in the dark web. So they came up with an example how to eliminate the intermediary, centralized banking authority. Okay, yes, let us join a peer-to-peer network, and let us have, if someone wants to transfer a money to B, let us make it as a consensus algorithm, or everyone should agree on a certain rules, and everyone is going to validate the transaction. And the example what I said is exactly something like a Bitcoin. So Bitcoin is one example of a blockchain, whereas in a blockchain you can take the same concepts and apply it to multiple scenarios or multiple examples. Maybe I will cite a couple of examples where we use blockchains. So now you have to understand, blockchain is not equal to Bitcoin. Internet is not equal to email. Of course, we know Bitcoin is an example use case of blockchain. So blockchain is the umbrella term. Bitcoin is one example use case. You can have many number of example use cases for blockchain. Blockchain comes as a generic framework and so on. The next point is about public blockchain and private blockchain. So generally, this is again another point of discussion in another seminar. Some of them were asking about this query, so I just added these slides to make sure this difference is explained. What is a public blockchain and private blockchain? So Bitcoin is an example of public blockchain. So when you say public blockchain, it's permissionless, which means anyone can join the blockchain network. Anyone can read, write, participate with the public blockchain network. So it's like you, me, everyone can join the Bitcoin network. We can hold cryptocurrencies. We can do the transaction. It's totally decentralized. There is no control over the network, and the data is secure. We will be as a part of validating the particular transaction. We can make transaction. We are part of the blockchain network. So basically, if you see the real use case of blockchain, it has to be public. If you see, anyone can join the network, and you can, which means everyone are participant of a particular blockchain network. Private blockchain is basically permission based. When I say public blockchain is permissionless, anyone can join. There is no permission required. It's public. To join a Bitcoin, there is no permission required. You can easily go and join a Bitcoin network. Private blockchain is permission. Permission networks has some restrictions. It's like literally, if you see in one of the videos, I have seen one of them telling the private blockchain is actually not a blockchain. You know, the power of blockchain is there in peer-to-peer network, and when it is anonymous and where there are more number of users, that is where the power of blockchain comes in. Private blockchain is permission by owned by, again it's moving towards the decentralized network, moving slightly oriented towards the centralized authority, you know, because it is owned by someone. Private blockchain, but still the working principle all go ahead with the working on the blockchain model. Permission network is like I'll tell an example of a private blockchain. Let me just say those who are generally working abroad have their need their certificates to be attested. You know, basically I have done my bachelor, masters and PhD. I need to attest my certificates. It's a huge task for me. You know, the whole timeline for getting attested with all the embassies and all the universities, and then coming and then getting the final attestation, it is a big task, because basically I have to go to the university and then I have to apply for the university for the genuinity of my certificate. It has to be attested by the human resources. It has to be attested by the external Ministry of External Affairs. Then again, if you see, this information has to be attested by, if it is UAE, it has to be attested by Ministry of Foreign Affairs and so on. You know, there are more players has to attest my certificate. If you turn back my certificate, or anyone who works abroad, if you turn back their certificates, there will be full of stamps, attested. You know, if these many seals represents, and this process is different for different countries. Again, different countries have different embassies, different attesting authorities, different notaries to attest it. And can you imagine, if you turn back the certificate, it's full of seals and so on. And behind this, huge timeline takes place. You know, it takes 1 year or 2 years or so on. It's not easy simply coming back and then I just telling in UAE my certificate is valid. They will say, prove that your certificate is valid. The same point comes in. How do you say whether something is legit or fake? It's on our part now. I have to move behind corners to corners, move to universities, move to how many times we have moved to different places to prove that my certificate is valid. I have to get a genuinity. I have to get it attested by the Ministry of External Affairs, Human Resources, Indian Embassy. I have to come back to the Foreign Affairs Department and so on. There in India, then come back to UAE, get all these attestations here, and finally they say, yes, your certificate is valid. You know, to say this, it takes a 2-year timeline. Now, I was imagining, why can't it have a separate kind of blockchain? It's very simple rules. It's a matter of verifying my certificate. Why can't a university be a part of the one of the participant in the blockchain? Why can't a Ministry of Human Resources be a part of the blockchain? Why can't Ministry of Foreign Affairs be a part of the blockchain? They are all in the blockchain. I scan my certificate and then I give it. They know the rules. They know whether it is valid or not. Once university approves and tells that my certificate is genuine and so on, and then every participant in the network can see it, they can validate, and then they can quickly say, in no time, my certificate can be attested. What can happen in a week's time takes for me 2 years to find out the attestation. This is the example of a private blockchain. People can work. You can think of many use cases for private blockchain. Now here, if you see here, this is permissioned. If you see here, can anyone go and join this private blockchain? No. For example, Anna University wants to join it. They have to be have the permission to join this blockchain network created by a private owner. Or Madurai Kamaraj University wants to join this private blockchain. Yes, they need to be permissioned and so on. So public blockchain is permissionless. Anyone can join. The best example is Bitcoins. Private blockchain is permissioned. You can't add all the players. You have to add the participants who are into this. It depends on the use case. The use case, what I said here is about the use case. What I told here is about the genuinity of the certificate. You see, there are different level of participants: universities, embassies, foreign affairs, and so on. Those who are looking at research-oriented thing, here you can work on either public blockchain or private blockchain. You can try to fix these issues, the disadvantages that are shown here. You can try to address on these issues, on the disadvantages, to make a public blockchain better. A public blockchain is open and permissionless network that stores fully transparent and public data, and so on. So you will see here the advantages are it is trustless, secure, and open and transparent, but it is slow. Why? Because if you see here, if someone wants to approve a particular transaction, as I told here, if someone wants to approve a transaction, every node has to validate the transaction. Imagine I'm going to a coffee shop and then I want to buy a coffee using Bitcoins. The Bitcoins are transferred from me to the coffee shop owner. But for this transaction to be approved or validated, it needs multiple nodes to validate this transaction. By the time I will give up the idea of drinking a coffee, it takes 10 minutes or 30 minutes to approve the transaction, and so on. Something like this. So there are scalability concerns, because when you say peer-to-peer network, it is open for everyone. It's like, can you imagine? It's anonymous, huge network, and so on. A private blockchain, yes, a private blockchain is faster because there are no, it's a closed and restricted network. As I said, the example of genuinity of a certificate, validating the certificate is an example of a private blockchain, and so on. Or another example I can say here about the organic foods. Another use case for the private blockchain. Imagine, as I said in the beginning of the presentation, how does someone says whether a food item is organic, really organic? Do you trust the label? You go to the supermarket, you see the product labeled as organic. Do you trust it? How do you trust it? Do you trust the label? Is it really organic? From where it has come? Can I trace it? Where it has come? Whether the seed is of good quality, whether there are no chemicals added to it while the plantation is grown, whether while it is transported, the proper temperature is maintained to these vegetables, and finally it has reached from the origin, from the seed level, from the origin, from the plantation level to the shelf. Can I track what exactly has happened? Is it following all the rules? Is it following all the rules that to be followed to be an organic? Just a label doesn't mean that it's organic, but how do I trace it? We are also working on a funding project on with blockchain, how to trace an organic food, any food product, tracing it from origin to the shelf. We are working on certain funding projects on it. Myself and my friend are working on it. So these are all the another example of private blockchain. If a private blockchain comes into place, yes, there are multiple players. Right from the plantation, there is a division there. They can be a part of the blockchain. One who transports the food items can be part of the blockchain. One who is the supermarket, or the supermarket could be part of the transactions. Everyone, and I am a participant. Everyone knows at what temperature it has been shifted, at what chemicals are added or no chemicals are added, and all those things can be traced back just by a click of a button from my mobile phone. So a closed and restricted network where only permissioned actors are able to participate in it. Yes, it's faster and it's scalable, but in the sense, because as I said in the beginning, private blockchains are not real blockchains. The power of blockchain is only in public blockchains. Why? Because in private blockchain there is some amount of centralization. This blockchain is going to be owned by centralization, which is going back to our basic fundamental telling. Centralization, the system is corrupt. Here there could be. That is why they say we need more trust, and then we need to provide better security, especially on private blockchains. Yes, those who are doing some research can work on this one. How to improve the trust on a private blockchain, how to improve the security on the private blockchain, how to make the centralization of a private blockchain little bit more decentralized. These things will enable a successful private blockchain models. In reality, we need that lot of use cases that requires. I have shared with you 2 use cases. One is tracing an organic food from the origin to the shelf. Number 2, about tracking my certificate genuinity. These things can happen. 2 use cases can happen in a quick span of time. All right. I hope you have some basic idea on having a blockchain. Now the next 2 slides, sorry if I'm running out of time, in the next 5 minutes, I'm going to tell you how to build a blockchain solution. So if you see here, it is very easy, very simple to develop a blockchain solution. It doesn't require, there are a lot of plug and play mechanisms today. Identify a suitable use case, find out a use case. How do I find a use case? In the sense, an example where I will apply my blockchain solution. Wherever there is central authority, wherever there is an intermediary that is taking more money. Redbus, I remember 10-15 years before, Redbus, they created an application, they never owned a bus. They were only targeting passengers and the bus owners. They were linking them together, and then that's Uber. These all, who is earning more? Is the benefit going to the taxi drivers or the benefit going to the passengers? Neither of them. The benefit is going to Uber, or the benefit going to the red bus owner, the brokerage, the broker or the intermediary in between. So find out a suitable use case where, looking at these 2 cases, where the system is more centralized, you can decentralize it. Where there is more intermediaries involved, you can cut on the intermediaries, the brokerage. Imagine today the whole world is revolving with brokerage. If you cut this brokerage out, and it's like it's a cakewalk business for each one of us, and mutually it's a win-win situation between the 2 parties. If you remove the brokerage, of course, every one of you will agree with me, I think, in this point. Number 2, identify a most suitable consensus mechanism. As I said, who is going to add it to the block? In terms of a public blockchain, as I said, who is winning the cryptographic puzzle? That is one example. It could be a round robin method. That is another example. There are other consensus mechanisms. Please understand, are we going to write a consensus mechanism? No, it's all inbuilt. Everything is there. You can follow any consensus mechanism to this. It's like a plug and play. Creating a blockchain is not difficult. It's actually a plug and play model. Everything is readily available. You no need to worry about writing it. Those who are working on a research may look for new consensus mechanism, like proof of work. You can write up a research. You can find out who will add this block. You can find out a new algorithm or the new rule for it. That those who are the professors working on research can work on this point, and so on. And identify suitable platforms. There are a lot of platforms: Ethereum, Hyperledger. Ethereum is for peer-to-peer network. Hyperledger, all are open source and it's free to use, and so on. There is no money involved. It's free to use. It's open source. You can download it. You can configure it on your phone, and so on. Of course, what we need a basic programming language knowledge. That's it. You can run your blockchain on Visual Studio, or you can write your blockchain on a Java program or certain scripts. Very simple business logic. Basically, think of writing a block as I can give you a simple example. Those who are good in object-oriented programming, you can think of a block as a class. That's it, or an object. That's it. It's an instance of a class. It has some attributes. It has some values. Think of a class having sender, receiver, and money. That's it. Very simple class. You go create an object for this particular class and add it to the block. The second point, as I said, in a block has to be immutable. You need to apply hashing to it, and I will share in the WhatsApp group later on how to create a blockchain in 15 minutes. One just maybe it looks like a 20-year-old was giving a demo how to create a blockchain in 15 minutes. He creates a class, he creates a block, and then applies a hash code. Everything is inbuilt. Most of the professors are working on, or the research scholars are working on Java programming or C# programming. All APIs are available for cryptographic functionalities. To find out the hash function, .hash code, the hash code is calculated. It's so simple to calculate a hash code and add to it. So I'll share it in the WhatsApp group, certain resources related to the implementation. So what is required from our side in general is a basic programming language and so on. That's enough to create a blockchain. There is nothing much. Most of the platforms that are readily available, what about the peer-to-peer network? The platform will provide. What about the consensus mechanism? The platform will provide. You have to define the use cases, you have to define the rules, and to bring them into the same network. That is where you have to design the admin and user interfaces, and then your blockchain is ready to go. And the last point here, adding future technology, you can also add artificial intelligence, machine learning, Internet of Things into your blockchain network to make it so innovative. For example, I have given you the example of tracing your food in the organic. One of the rule I said, how do I say this vegetable is organic? While transported, it has to be maintained on a particular temperature. Is it maintained on a particular temperature? Do I look for manual entry? No, you have to go for IoT sensors. So in the sense, your IoT devices can be part of your network. They can measure, they can sense the temperature of the room temperature where the vegetables are kept in, and they can update it. So the rule can say, is it maintained in the appropriate temperature? If yes, the others can validate your transaction and it could be added. Otherwise, you can rule out. It is very easy to track a particular product. Of course, you can think of adding any future technology, artificial intelligence, machine learning, and Internet of Things. This is where the innovation starts. You can, it's very powerful point. How do you add future technology into a blockchain? So think of multiple ways how future technologies can be added to a blockchain. In our case, we are looking for we are working on a blockchain solution with integrated with Internet of Things and so on. So those who want a simple, I want even more simple. I don't want to follow all the steps 1, 2, 3, 4, 5, 6, 7, 8. I don't want to follow this all the steps. Those who want to keep it even more simple, of course, many should be offering. IBM offers blockchain as a service. Of course, it's blockchain as a service. Imagine BaaS. IBM has done everything ready-made, and then, but I think it looks like it should be commercial. You just buy it. It's like a plug and play. You can add participants. You can create your own blockchain network for your college or something like that, for your network and so on. You can look at this case. It is much more easier to implement because all the hurdles of blockchain are solved. Of course, if you see, IBM is also using in point number 3, they are using Hyperledger platform. So either you go by this if you want to go for free. Otherwise, there are commercial applications where they have solved all the problems. Only thing is, we have to build up the interfaces, add some rules, add some participants into it, and so on. If you see here, make blockchain real for business. There are a lot of use cases that are coming now. People are going for blockchain as a service with a cheaper cost. And you see all the keywords here. I hope you understand the keywords. Shared ledger. I said it is not in one place. It is in distributed in a peer-to-peer network. It is secure, tamper-proof. I said yes. It's immutable. You cannot go and change it. If you change it, the hash code will change. Permission participants. When you say permission, this is talking about a private blockchain and so on. Private and auditable. Yes, it's auditable. Consensus protocol. I just said proof of work, round robin example. Smart contracts. So that's the point which I left, especially smart contracts. If you see here, I just said I will add it later on. If you see point number 3, these are computer programs that enforce and execute the statement of contract between organization, people, and things. That's a smart contract. You can imagine smart contract as a set of rule. Smart contract as a set of rule where the participants can join your particular network. When you say tracing this organic food, who are all could be the participants? It could be a Lulu supermarket or a Reliance supermarket. Could be part of the participant. It could be a transport department transporting the food items. It could be the seed manufacturing factory could be part of this blockchain network. All these participants has to agree on a certain rule. These rules are written as programming business logic in your smart contracts. So typically, to see what you are going to write is, you are going to create participants, you are going to write your own rules on your agreeing on the terminologies. For example, if you see in a genuinity certificate, when the certificate can be attested, they will look at my degree, they will look at my degree number, and then they look at their database, and then they approve my transaction. How does Ministry of Human Resources approve my attest my certificate? They see whether the university has issued genuinity. That's the rule. If genuinity is issued, the Ministry of Human Resources will approve this transaction, and so on. So it's a matter of, as I said, the participants, every participants approving this particular transaction, and so on. If you see here, this is not only IBM, I'm sure other players are also offering blockchain as a service. So you can go for other players, and so on. And the last point about research challenges in blockchain, as I said, time to time, look for the disadvantages of private blockchain and public blockchain. Professors can work on that to solve those problems. In the research, they can use Hyperledger or Ethereum platform. You can work on a new consensus algorithm. You can work on the advanced cryptographic techniques that can enhance the privacy in private blockchains. And in private blockchains, there is no bitcoins involved, cryptocurrencies involved. So you can also think of using the existing money model, existing banking system into the private blockchains. For example, for genuinity, I need to pay some money. Can I interlink banks to it? Think of it, and then how to interface on it, and so on. And we all know the blockchain performance degrades because it's in a large scale network. You can also find out a way how to optimize the blockchain platform performance in a large scale network, and so on. So that is where I hope I have covered all the point. I should wait for some questions. Thank you all for participating in this, and I always say participation is the key to success. All the best to each and every one of you. If you have a query, you can write it in the chat. I'm opening this timing for question answer session. You can note on my email ID for any seminars, guest lectures, or if you want to have any query also on a blockchain, or my major is networking and security, you can write to me. And I found this phrase very interesting. Every once in a while, a new technology, an old problem, and a big idea turn into an innovation. I hope all here are future innovators. All the best for you, and I'm open to the questions. Thank you very much, and waiting for your questions. Yes, ma'am.
Hello. Hello.
Yes, sir. Yes, sir. Yeah, please. Yeah.
Yeah, sir. My question. I think Bitcoin, when it was launched, so it was using the similar technology of blockchain, but it was there was some issues with Bitcoin, and it was getting flopped at the subsequently. So what was the reason actually? Yes, sir.
So actually, in the Bitcoin, as I suggested, there is Bitcoin was knowingly or unknowingly following the blockchain model. Knowingly or unknowingly following the blockchain model. They don't have any what do you say? They don't have any proper framework. In fact, if you see the Bitcoin paper, you will not see a single word written as blockchain. The Satoshi, who invented Bitcoin, did not even mention anything on the blockchain. So from there originated the keyword of blockchain. To answer your question, so it looks like more of a unreliable, because sometimes that it looks like your what do you say, your trade market. Sometimes it is the value is high, sometimes the value becomes the value of the currency becomes low. So that is where people are not still trusting it. Many countries are not approving the Bitcoin. Once the currency stabilizes, the cryptocurrency stabilizes, then it will have a better future. It looks like that, but I am sure it will have a better future. Yeah.
Okay. Right. Thank you.
Yes, sir. Any other questions? Yeah.
So there are two more questions in the chat box.
Yes, yeah, please. Can you read it, ma'am?
Mr. Ranjit, he has asked that is dark web working under blockchain technology?
No. Dark web is different. It's not working under blockchain technology. Bitcoin was initially working under dark web because this was used for illegal purposes, drug selling, buying, and so on. So that is where people they found they don't want. They are illegal users. They literally this technology was found by hackers. They are illegal users. They don't want to use the actual banking system to transfer their money. They don't want to be caught. That is where they invented Bitcoin, and they were using it in the dark web. Once this concept looks the working becomes a working model, then it has come to the reality now. People started to use Bitcoins now in real time. It is nothing to relate with what do you say? Dark web is not working on to answer your question straight. Dark web is not working on a blockchain technology.
One more question from Ms. Sasireka. Which is the best tool to use blockchain technology?
Sasireka ma'am, you can use basically you can use Visual C# code to write your blockchain business logic. You can use your Java programming, or you can use your Visual C# code basic programming. That is where if you see people are generally taken back telling blockchain means they take a step back. They are not putting their foot in only because they don't know the logic behind it. But if you see, it's a basic programming. You can, most of the professors here, you can give it as a blockchain project to your final year students or your third year students. A student who are good in programming language straight away can go and create a blockchain on it, and so on and so forth. It is as simple as that, but at the same time, it's not as easy what I say. But if you have a basic workout model, it is very simple. In the WhatsApp group, I will share some video links on how to create a blockchain and so on.
Good afternoon, sir.
Yeah.
So is there any difference between cryptocurrency and digital currency?
Yeah, most likely Bitcoins are cryptocurrencies. Bitcoins are cryptocurrencies. Yeah.
And Ms. Preeti has questioned that to give few examples of private blockchain.
Yes, he said private blockchains. Yeah, there are some private blockchains. Maybe I'm not sure whether the slide is there. I can share some use cases. Yeah, I'll share it in the WhatsApp. There are of course whatever we are doing in a private blockchain. I'm not sure how it missed. Let me just check. 1 second. I can find out. Yes. Yeah, I'm just sharing the presentation. Yeah, I hope you are seeing it. Yes. Yes. Are you able to see it, ma'am? Yeah. I don't know how this point got missed. This slide got missed. You can have a look at this 50 plus blockchain real world use cases. Most of them are private blockchains here, especially on the border control, supply chain, healthcare, land registry, energy sector. I don't know how I missed this slide, but these are all the real world use cases of private blockchains. I will share this in the WhatsApp group, the presentation as well as the PDF. Are you seeing this slide, ma'am? 50 plus blockchain real world use cases?
Yes, it is.
Yes, yeah. That's to answer your question. This is your
answer. Dr. Shanti, ma'am, she has asked that decentralization may lead to waste of memory.
Decentralization?
May lead to waste of memory. Just a question.
Yeah, of course, yes. There is always pros and cons, but today there are, we don't have we have a lot of solutions. It's like the nodes are sitting on the cloud. You can have a cloud-based node, and there are proper memory management in the cloud and so on. So these are all solvable problems. Yeah, but it improves the trust.
And one more, Professor, they have asked, any built-in model available like ML? Any built-in model available?
Built-in model in the sense, that's what I have given the steps to develop a blockchain. If you want to go in a commercial aspect, you have to go for many private vendors are going for blockchain as a service model. So you can if you use blockchain as a service model, it's actually plug and play. You go select your consensus algorithm, you write your business logic. It's like a plug and play and create your own blockchain. You can create your own blockchain in minutes, kind of thing. It's like as quick as possible. But I think it should be a little bit, when you go for more comfort zone, you need to pay a little bit, I think so. But if you are ready to work on open source right from the scratch, of course, there are a lot of tutorials available. Then you need to spend some time on it. Yeah.
And one more question from Mr. Ranjit, sir. He has asked, please say private blockchain real-time application.
Yeah, I just shared the 50 plus use cases of. I just shared the presentation, right? 50 plus blockchain use cases.
Yes,
this
sir.
one.
Yes, sir.
I'll just again, maybe I'll share it in the WhatsApp group once the question answer session is over. Yeah.
Yes, sir. Any other queries, professors? Any other queries? Is there any disadvantage of blockchain?
Yes, there is a disadvantage of blockchain. I have given there what are all the disadvantages of private blockchain and public blockchain. If you see my presentation, I have given it there. As professors, please work on. You can work on solving these problems. If you look at, as I said, in public blockchain, it is slow. There are some scalability concerns because there are too many numbers. And if you see, as I said, I gave an example of a coffee shop. You want to buy coffee using bitcoins, maybe you need to wait for half an hour to drink a coffee. In a private blockchain, as I said, actually private blockchains are not real blockchains because it's moving towards centralization. There is poor security. You can work on improving the security and the trust. Why? Because they say trust is needed and the security is lower just because of this centralization. Whenever there is centralization, the trust is less and the security is less, and so on. It looks like, looking at your questions, I am happy that you are in line, you are connected to my presentation. Thank you very much. Yes, go ahead.
Yes, so one from YouTube live session, Mrs. Cheryl Sokesh has asked, can blockchain and machine learning work together?
Yes, yeah, that's what one of the point I just added. Yes, of course, yeah, you can. It's up to your innovation. Yes, how to, as I said, one of the point here, adding future technology. Yes, you can. Artificial intelligence, machine learning. Sorry. Yes, Internet of Things. It could be used. Yes, it's
can we use MATLAB?
Can you use MATLAB? I'm not sure about MATLAB, but we can use, I'm sure, Visual Studio and the Java programming and Node.js scripting for writing your blockchain scripts. It depends on the platform, yes, the YouTube viewer. It depends on the platform. If the platform supports this, so if you go at Hyperledger or Ethereum, just go through the platform. What are all the programming language support does this platform provides? If for example, I am sure Hyperledger supports Visual C# code. So yeah, of course, that's what I just said. So people are asking what type of programming language you can use. Yes, Python, Visual Studio, or Java, or MATLAB. It depends on the platform usage. If you see point number 3, I have mentioned here in point number 3, identify the most suitable platform. You are going to choose Ethereum or Hyperledger, or there are even more platforms. I didn't mention it here. Maybe I can share the more platforms in the WhatsApp group. If you see these platforms, if the platform supports, yes. So we don't remember which platform supports what programming languages. Of course, you can go through it. Yes, I'm sure all the front end, all the latest programming languages should be supported by the platforms. It's an open source platform and it will support it.
Any other queries, professors? I think that's all, sir. So can we wind up with a vote of thanks?
Yes, ma'am. Yeah, yes, please.
Okay. Anto, can you please start with a vote of thanks?
Yes. Again.
And before the vote of thanks, I thank all the professors. Thank you, Dr. Benson, sir. Thank you, all the professors, and sorry for the 10 minutes delay, which happened due to the live YouTube session. There was a delay in that, but by the grace of the Lord, it happened successfully. Thank you, everyone, each and everyone, for making this webinar a successful one. And kindly proceed with the vote of thanks.
Etc. Give thanks to the Lord, because he is good. His love is eternal. 1 Chronicles 16:34. Gratitude is the most delicate form of courtesy. We must always find time to thank great people who make differences in our lives. I extend my sincere gratitude to our patron, Reverend Sister Dr. Arokya Rani, Secretary and Principal, for her support and guidance in organizing this webinar. I extend my thanks to our resource person, Dr. S. Benson Edwin Raj, Associate Professor, Department of Computer Information Sciences, Higher Colleges of Technology, Fujairah Women Campus, UAE, for accepting our invitation in spite of his busy schedule. I extend my sincere thanks to Dr. Dina Suresh, Head Department of Computer Science, for her immense efforts in organizing this webinar. I am very much thankful to all faculty members of Computer Science Department for their valuable contributions, arrangements, encouragement, and all-time support in organizing this webinar. I extend my thanks to all enthusiastic participants for their valuable and active participation in this webinar. Thank you, everyone.
Yeah. Thank you, everyone. Thank you. Thank you.
Thank you, sir. So any other queries or thing, we can have it in the WhatsApp group. It will be active for another 2 or 3 days. You can also, the sir has given his mail ID. So any other queries, you can question sir also. Thank you each and everyone. Thank you, professors. Thank you once again, sir. Thank you. We'll end off with the session.
Mail ID is there. Yes. Thank you very much. Yes.
Kakak.